Welcome to the second session of the Satellite Data Processing Tool. For this session, we're going to be looking at SNAP, the Sentinel Application Platform. So we're going to explore the software itself briefly, and then we're going to highlight some of the capabilities of the software. Let's get started. The Sentinel Application Platform provides an opportunity, a common architecture for all the Sentinel toolboxes. So the toolboxes are made up of, they consist of the algorithms that have been designed and developed to process the satellite Earth observation missions. And these Earth observation missions are usually global in their coverage, and they consist of radar and multispectral imaging instruments. So in order to process this data, European Satellite Space Agency with some of their collaborators, have designed various toolboxes to ensure that the capabilities of the data, what is possible with the data, is actually enhanced. So those toolboxes are there to process this data and turn them into useful information. So within SNAP, all these toolboxes are made available. So it's a common architecture holding all these and providing a framework by which these toolboxes can be used. SNAP is very fast with image display. So even when it's trying to display huge and gigabytes of data or imagery, it's very efficient and very fast in doing this. It allows for programming of processes that you actually do over and over, so you can program them as a series of tasks that needs to be done. So instead of having to do them one by one, you can link all these tasks together and create a kind of program, a visual program that you can activate, and it can carry out all the processes, all the tasks within this process at a go. You can work on area of interest, you can create plots, you can create statistical analysis, result and output, focusing on area of region. So you can, from a big scene of data, you can focus on area of interest for you, and you can generate different statistics and plot out of this. There's a flexibility in the way it handles different bands in order to create mathematical expressions that can be used to derive new and additional information about the data set. There is opportunity for rectification, geo-rectification, and geocoding using ground control points to ensure that the data fits adequately with what is on the ground. So these are just some of the highlights, some of the common things that you can attribute of the software. Now, let's see, what do you need in terms of what are the requirements for you to install the software. First of all, you need to remember that this is an open source software, so which means it's available for free and it's constantly being modified and developed. The minimum hardware requirement is 4 GB of RAM and either a 32-bit Windows operating system or a 64-bit operating system. You can install it also on a Mac system, a Macintosh, or a Linux operating system. So unlike CDAS that is only available for Mac and Linux, Windows can also, the software can also be installed on Windows in the case of SNAP. So a bit of comparison there. CDAS works on Mac and Linux. SNAP works on Windows, Mac, and Linux. So you can also, it has a user interface, a graphical user interface, so you can actually point and click, or you can also use the command line. So it has the opportunity for you to use these two different approach into executing tasks. There is a wide range of data converter within the system, and it can entertain a wide range of data formats. You can download data from this site, or you can download directly from the SNAP platform once you are connected to the internet, and you have the permissions, so which means you have to register in, on all of these different data access platform that we discussed in the previous lecture. So you can put in your login details into the software, and you can have direct access to the data. So you can take the data from the data archive and bring it directly into the Snap platform. So everything can be done within the Snap software. And for you to download the software, here is a link for you. So we are going to be using the software instead of CDAS, because I know most people will not have Linux or Mac operating system. So we're going to download the Windows version of the software, and we're going to be using that for the practical exercises that we're going to have later on. So let's now dig in a little bit more into the capability of Snap. You can import data from various satellite missions. You can use the standard S3 or ArcGIS shapefile within this platform, and some other established software like MV, Elders, and the rest. You can use those formats within Snap. You can import field and institute data for analysis within Snap as well, and there is a whole range of data processing options. You can process radar data, imagery, raster, and so many other data formats. As well, you can do some calculation on the data. You can also do image processing like classification, image classification, object detection, and so on and so forth. Data plots, statistical analysis, and various visualization capabilities are also within the system. So it's a very it's an all-encompassing software which can handle a wide range of operations and data format, as well as products, Earth observation products. So it's very, very versatile. So many of the things you can do with CDAS, you can also do with Snap. So while Snap is more or less programmed towards processing Sentinel data, it also has the capability to process a lot of the data, or the Earth observation mission data, from the American, the National Space Agency, the American Space Agency, NASA. So it combines the two. So what you can do from data from NASA Earth observation mission and the European Space Agency, you can process them within Snap. So we will move now to look at the graphical user interface. At the top, you have right at the top here, you have the menu bar, the main menu, and then you have the toolbars right here. You have the Product Explorer right below that, where you can, just like your window file explorer, you can look at what you a particular product. Once you have inputted it, you added it to your display, you can look at it closer. So let me bring this to your attention. So this is an example of the data set that I've loaded onto the system. We have the Product Explorer. This is the product, all the content. I can explore it through here. Pixel information, as I'm pressing and selecting any of the pixel, I can get more information about them. We have the navigation here, so if I want to move, pan and zoom to different areas, I can do that here. Okay, so I can do that here. Right here we have the Bonny Island in River State. So we can do that here. We have the color manipulation, we have the uncertainty information, and the world view. This gives you an idea of where you are relative to the entire planet, where your data captured. which area is your data capturing. Ooh, that's a little bit too close for comfort. So anyways, so that gives you we have the mask manager. So if I want to narrow down my data to certain area, I can create a mask that this is only the area I want to focus on processing. So at times, if the data is too big and you don't have the computing capacity to be processing everything, you can create a mask that will just narrow your processing to a particular area. We have the layer manager, so different layers. So I have just one layer showing up here right now. So if I create more layers, it will show up here. Then we have the product library. So from this area, I can navigate directly to different platforms and use, so you can see USGS. If I have my login details, I can go directly to the USGS platform, the Earth Explorer, the Alaska Satellite Facility, and so on. The Scientific Data Hub, that's the Copernicus platform we looked at earlier. So if I put in all my login details, the account and things like that, I can be able to access the data and bring it in directly into my Snap platform and start processing directly. So you can see the platform has a whole range of things that you can do. Geometric analysis, there's some applications that have already been designed: object detection, noise speed detection, urban area speckle divergence, change detection, and so on. There's a whole range of things you can do, from processing layer, vector layer, and manipulating raster dataset. So in our practical class, we'll explore more what you can do in the software, within the software, and we'll do some practical exercise with some specific problems, trying to address them. So if we round off here, we'll see that we have successfully gone through what Snap can do. Snap can give us an idea, can give us a platform, provide a platform for us to access, process, analyze, and visualize remotely sensed data. It has a graphical user interface as well as the command line prompt where you can actually process. But for now, I'm not going to explore the command line prompt, so we have focused more on the graphical user interface, and in the practical we'll also look at that. It has support for Windows, Linux, and Mac operating system, support for many Earth observation mission and direct data access. It has support for ancillary data and in-situ data or field data analysis. So there's a whole range of things that you can do within this platform. So right now we've come to the end of the session 1, and I'm going to introduce you briefly to what we're going to be doing in the practical classes. So for the practical classes, we're going to use 2 different Sentinel Sentinel missions, the Sentinel-2 mission and the Sentinel-3 mission. Each one of them have different characteristics, and they are useful for different operation or different Earth observation or resource management capacity. So we're going to use the Sentinel-2 to map water bodies within a particular area, because water bodies are also quite dynamic in the rainy season, in the dry season, in different part of the country or different part of the planet. They are also quite dynamic, so there is a need to monitor them to see how they're changing as a result of human activity or as a result of climate change and so on. So we're going to look at that using Sentinel-2. We're also going to map ocean color using Sentinel-3 OLCI. I'll tell you the meaning of this when we get into the exercise. And we're going to use this to see whether we can map out algal bloom and understand the trophic state or status of particular water body of interest. So this is what we can expect in the practical classes. So this brings us to the end of the satellite data processing tools, and I hope you can briefly explain what you have learned in this lecture. I'll provide a link now within our learning management system so that you can explain what you have gained from this particular exercise. And I'll see you in the practical exercise. Bye for now.